Hypothesis testing basics. A hypothesis is a statement made about a population parameter. As an example, if we consider the introduction of a new drug, drug Y, as discussed in the introduction, the statement might be about the cure rate. As another example, if we are considering the introduction of a new fertilizer, there may be a statement about crop yield. The hypothesis can be tested by carrying out an experiment or taking a sample from a population. From our experiment or sample, we will calculate a statistic related to the population parameter under consideration. So up here, cure rate or crop yield. This statistic is known as the test statistic. It is this test statistic that we use in a test to investigate the statement about our population parameter. The approach taken is to form two hypotheses. The null hypothesis, usually termed H0, is the hypothesis that you assume to be correct. This is usually the situation of no change. So in the example of our drug test, the null hypothesis would usually be that drug Y has the same efficacy as drug X. So that's the situation of no change. They are equally effective. The alternative hypothesis, usually termed H1, tells you about the parameter if your assumption is shown to be wrong. The alternative hypothesis may take different forms depending on the situation. If the alternative hypothesis takes the form that the parameter P, or probability, is less than a certain value, or that it's greater than a particular value, we get what's known as a one-tailed test. If we return to our example of testing drug Y, the null hypothesis is that it has the same efficacy as drug X, the drug that is currently in use. Since we are wanting to know whether the new drug is better, i.e. cures more people, the alternative hypothesis would be of the form that P is greater than. So our tail would be at the top end. Suppose we have 30 people in the drug trial. We decide on a significance level, we'll talk more about that later, for the test, and according to the probabilities involved, so we had 30 people in the test, and we find a critical region that goes from 27 people upwards. In other words, if 27 or more people are actually cured by the new drug, then we would have cause to reject the null hypothesis at the significance level that we're working at. So this region, known as the critical region, is the region within which we would reject the null hypothesis. If the alternative hypothesis is of the form P is not equal to, we get a two-tail test, and that has a critical region at either end. So there would be a critical region at the top end like this, but also another one at the other end. Typical significance levels might be 10%, 5%, or 1%, and you will be told what to use in a question. For something like replacing drug X with drug Y, a very high level of significance may be required, and that's because of the cost involved with replacing an existing drug with a new drug. You really want to know that if you're going to that expense, that the new drug is going to be more effective.